fg of t plus 0 multiplied sine 2 pi fb of t. We can represent that point like this. A simple way to do this, but may not be the best way. Maybe a very bad way. but it's something I can think of at this point.
I just seeing when I'm saving, and that's what it came to my mind, pictures that they asked to choose, 8 bits, 16 bits. And,
the more number of bits, the more color you can differentiate.
Okay.
Yeah. For example, this is an 8-bit. This is actually an 8-bit because we have a range from 0 to 225, to 255, which is 256 numbers, 256 different values.
Right.
Right. This is 8-bit. So if you save a picture into 8-bit, so that's not related to this signal stuff. Yeah. If you save a picture into 8-bit, then you have all this range is 0 to 255, and all of them has to be integer. They have to be integer, right? Because we can only, with the 8-bit number, we can only represent 256 numbers, values, different values. Now, with a 24-bit, our range is still from 0 to 255. But we can represent 2 to the power of 24 different values in between. So we can have 0, we can have some decimal points, which is more precise. And that way we can specify much more different colors in the picture. So if you save it with a higher bit, then you have a better picture. It's something related to that.
Right.
Yeah, number of bits. A lot of different interesting stuff.
Yeah. Now, it will take more time to say that.
And more memory.
And more memory, right?
Yes.
So that's the...
Because in
And it will be
computer-
a high resolution
Yes.
picture.
Yes. And if you have a high resolution, then you need even more memory.
Right.
Yeah. A high resolution means you have more pixels.
More pixels.
Yes.
Right.
Means you have more pixels. So that way you're going to have you're going to use a lot of memories. I remember I'm taking, nowadays those cameras, you take a picture easily, right? 10 meg.
Right.
Easily make a 10 meg.
But then you will use all your memory.
Yeah, so I reduced them.
Right. Right.
I reduced them.
Right.
But yeah, most of the time I reduce them to maybe 2 meg. 2 meg is good enough.
Right.
Yeah.
But they want you to buy, they are selling you,
Yeah.
a 10 meg.
Yeah, but you
So
never use it.
You don't ever use it. Yeah, but you buy it.
because they don't make those cheap ones anymore.
I know.
Yeah?
Yeah.
They don't give you a choice. They force you to buy the expensive one.
Right. Right. So help me understand this. When I'm still confused with all of this. So in the conversion of from analog to digital, in the analog you have more points. Right?
Yes. In analog, it's like I have a real function,
Right.
sine of 10t. I plug in whatever value of t, I can get a value. I can get a number of sine out from there.
Right. But why then why are we converting? Oh, to analyze. We convert to digital.
Because we want
To analyze.
we want to have the signal into our save the signal into our computer.
That's right.
Yeah, but computer cannot recognize something like this because it's digital computer. Now, if some people in the future they build analog computers, powerful analog computers, then yeah, we don't need AD converter anymore.
Right. Right.
And that would be very nice because human brain is analog computer.
Right. That's the reason we don't understand it, right?
Yeah, right. That's the reason we can understand a lot of different things, but not our brain.
Our brain, that's right. Yeah. Okay. Cool.
Thank you.
All right. So I like to ask the students, do you see any application of this, your data collection?
We're using low pass filters and high